Hello, grade 10 students. I'm going to show you, like I promised, how to solve these last two on the assignment. I hope you've had a little look at the latest sheet I posted yesterday. It's on solving systems. Oh man, talk about the gifts I give you guys. The gifts. You're going to find out where these two lines intersect. No graphing. Because a lot of you don't like graphing. A bit of a pain. Okay, solving a system means, well, a system is, it can be more than one equation. Almost your whole high school career, a system is just going to be two equations, two linear equations for the most part. They're two lines, and you want to find out where they cross. So to solve a system means you're going to be given two lines, and the solution is where they cross. And the where they cross is the one point that's on both lines. As I said in the exercise, you want to think about that. Now these last two are kind of weird, but it happens, and everything makes logical sense. Watch. I'm going to do the same procedure I did with the other ones. Hopefully you gave it a try also. Otherwise, you're not supposed to be here. It's a spoiler alert. All right. I'll call this equation 1 and this equation 2. Okay, so equation 1, I could say from 1, they used to do this when I was in high school. From 1, because you always want to have a nice solution that makes sense and it unfolds. I'm going to take, I got x minus 4y equals 8. So I want x isolated on one side. I'm going to take the other one, go whoosh, put it on the other side. Okay, just x, all by your lonesome. And I'm going to move the negative 4y over here, becomes positive 4y. Beautiful. Now, I'll take this expression for x and substitute it in equation 2 for x. So equation 2 says this: 2 times x minus 8y equals 8. So instead of this x, I'm going to replace it with 8 plus 4y. The reason why I do that, it's basically the x here is the same as the x in there, only at the point of intersection. So I'm allowed to do that. But it also, the wonderful thing it does with this technique is now I don't have an equation with an x and a y. I have an equation with only y's. And I can solve it. And I can find out what the solution is for y. And that solution is the y coordinate of the point of intersection. So I've gone through this in the handout. Do you call it a handout if it's not really a solid piece of paper? It's, I don't know what to refer to whatever it's, look at the handout, look at the sheet. It's not a sheet, whatever. Okay. 2 times 8 is 16. 2 times 4y is 8y minus 8y equals 8. Look at this, 8y minus 8y. That's 0y. These two terms cancel each other out. And what am I left with? I'll write an extra step here. I'll say this becomes 0y. That's a funny looking 0. I know, don't worry, I haven't been drinking. And it equals 8. And now, so what I have is y's gone. And I have, that whole term is gone. 16 equals 8. Now, if I'm a math teacher and I tell you that 16 equals 8, I should be fired. 16 does not equal 8 in our universe. Maybe on a Star Trek episode it does. But this means this is incorrect. This is wrong. Whenever you move from line to line, logically, and you come to a contradiction, this is a contradiction. 16 does not equal 8. That means this cannot happen. It means your original assumption was wrong. What was my original assumption? That these two have a solution. this means they don't have a solution, which means they don't intersect. They never do. What pairs of lines never intersect? Parallel lines. These two are parallel. They're parallel lines. Let me prove it. So whenever you end up with two numbers equaling each other and they're different numbers, that means you got parallel lines. And you could, let's think about this logically also. If they're parallel lines, let me put this in y equals mx plus b form. So we see what the slope is. Negative 4y equals, I'll throw the x on the other side. Okay? And then I'll divide both sides by negative 4, and I will have 1 over 4x minus 2. Okay? So this, in y equals mx plus b form, is y equals negative 1 over 4x minus 2. The second one, I'll do that to it as well. Let me put a big line there so I don't confuse things. And I'll have negative 8y. Moving the x term over on the right-hand side will give me a negative 2x. I hope you can see this. And then plus 8. Okay, now I will divide both sides by negative 8. Negative 8, negative 8, negative 8. What do I have? Y equals 1/4 x minus 1. So the two lines written in different forms are this. Line number 1, line number 2. This shows you that they're parallel. Why? They have the same slope. So they're right beside each other. But this one has a different y-intercept. They don't have the same y-intercept. Excuse me, I have to get this off my screen. They don't have the same y-intercept. They're different lines. You don't have to show this. I'm showing you this now to convince you that the result I obtained here shows that they're parallel. When you go through the regular substitution method and you end up with this sort of result, this tells you that they're parallel. If you want to check your work, put it in y equals mx plus b form. You say, oh, of course they're parallel. They have the same slope but a different y-intercept. So they both slant at the same angle and they never cross. Never. There is a branch of mathematics. And I don't want to talk about this. This is going to, you'll get weird. You'll have nightmares. Okay, I'm going to erase this because you have it on video. And, sorry, I thought I saw a centipede. I live in a basement apartment, and sometimes I get centipedes, especially when it gets a little rainy outside. I don't like centipedes. They're creepy. They give me the creeps. I'm afraid they're going to crawl in my face in the middle of the night. All right, I need the other one. Doo-dee-doo. I think it's the last one. This last one gives you a funny result, too. This is number 8 in the practice of yesterday's sheet, for lack of a better name. X plus y minus 4 equals 0. And then 2x equals 8 minus 2y. So there's two snags you could run into when you want to find out where two lines cross. One is if they're parallel, and that means they never cross. This is the other situation. But also we get a result that logically points to our snag, so to speak. Okay, this is, I'm going to call this equation 1, and this is equation 2. So from 1, I want to isolate. Let's isolate y. Just to be different, we've got x plus y minus 4 equals 0. Okay, and now I'm going to put everything that's not an x term on the other side. So x equals negative y plus 4. I'm going to take this expression for x and replace in the second equation the variable x with this. And good things will start to happen. Okay, from 2, we say 2x equals 8 minus 2y. So I'm going to replace x here with negative y plus 4. So 2 times negative y plus 4 equals 8 minus 2y. Minus 2y plus 8 equals 8 minus 2y. Do you see where this is leading? This leads to another strange result. Okay, let's put the y's on this side and the 8's on the other side. Okay, negative 2y, and I'll bring this one over. It's a plus, sorry, negative 2y. Bring this over, you got a plus 2y. Y. And here we have 8, and I'm going to bring this 8 over. I get minus 8. What do I have? I have 0y equals 0. I get 0 on both sides. When does 0 equal 0? Always. For what x values does 0 equal 0? Any x you want. For what y values does 0 equal 0? 0 doesn't care what x and y are doing. It's not even involved in here. It's gone. There's no x, there's no y. 0 equals 0 always. This is called a coincidental solution. Why? These two lines are more than parallel. They're the same line. These are the same line. They're exact same line. They lie one on top of each other. So where do they intersect? At every single point. So they often say the solution I don't know what they do these days. You could just say it intersects at all points. Intersection at all points. So that's the two odd results you can get that are possible. And when you think of that, there's only 3 intersection at all points. I'm getting ahead of myself. There's only 3 possibilities. You have 2 straight lines, okay, and they're in one plane. They're either going to intersect at one point, or no points, they're parallel, or all points, one's on top of the other. These are the 3 results. This is how you determine it. 0 equals 0 will be the answer, meaning they intersect at all points. Something crazy like 0 equals 100 doesn't make any sense. That means your original assumption was wrong. The assumption that they intersect, they don't. This assumption is fine. You know, we get a result that makes sense because they do intersect at every single point on each line, one on top of the other. Okay, so that's for this situation. What I'm going to do is that we got one more method to learn. I'm going to post that Wednesday, Tuesday, Thursday, something like that. And then I'm just going to have one assignment. This is like a mini unit that's going to deal with intersections, solving systems of equations. The other method we're going to learn is called elimination. They're all important. Graphing is very obvious. As soon as you learn how to graph a line, I could ask you to solve a system by graphing. You could do that. You just graph 2 lines and you see where they cross. These other ones, it's a little bit of algebra, but you guys are tough math students now. You can handle this. And then I'm going to show you the other way, and then we're done intersection. These are both, it's important stuff for math. It's going to come up. I'm hoping you have a strong handle on factoring now. We did in the last unit. You're definitely going to need that in grade 11. And we're going to need intersection. You're going to need that in grade 11. And then in June, it's going to be mostly quadratics. So instead of straight lines, we're going to look at a certain type of curve. Like McDonald's. Everybody loves McDonald's. I don't know why do people like McDonald's. It's not the healthiest choice, but it has 2 golden arches. So that's the shape we're going to look at next, is the golden arches. You know what? My son's on the phone in the next room, so while he's gone, I'm going to eat his food. Okay. Stay warm, stay distant. Keep rocking. I'm trying to find. How do I end this video? Oh, here we are. Okay, guys, see you later.